Welcome to my video on the chain rule of differentiation. This is lesson number 15 in my calculus tutorial series. So first of all, let's look at the basic definition of the chain rule. And if you remember in the last video, we talked about this composite function, and so we're going to be using that again here. So if g of x is differentiable at x and f is differentiable at g of x, then this composite function is differentiable at x, and so this is going to be the relationship right here. So this is the chain rule written in one form. We're going to write in three different forms, and you'll see them in different forms depending on where it appears. But this f composite g prime, the derivative evaluated at x, is equal to f prime evaluated at g of x times g of x prime evaluated at x. So it's a product of those two functions. Now we can write this the other way. The derivative of f evaluated at g of x is equal to just what we saw earlier, f prime evaluated at g of x times g prime of x. Now if we write it purely in the Leibniz notation, we can break it up into dy dx is equal to the product of dy du times du dx, where g of y of u is g is f a function of u, and u is equal to f a function of x. So we put these, that's what we're going to work with to do. So there's our basic definition of the chain rule. Let's do an example. So we want to find x squared minus 1 raised to the 10th power. Now, that would get rather messy if we had to expand out x squared minus 1 to the 10th power. So we're going to use our chain rule. So what we're going to do is we're going to let u of x be equal to x squared minus 1, and this y of u be equal to u to the 10th. So we're going to make this substitution. Now, taking the derivative of this dy du is going to be equal to 10u to the 9th, so that's the derivative of this. Now the derivative of du dx is just going to be equal to 2x, so that's the derivative of this function. And we're going to need those if we're going to use our definition earlier, where we have the dy dx is equal to dy du times du dx. So we've got all of those now. So what we want to do is, so this dy dx is equal to, now our first term there is dy with respect to u. Okay, that's just 10 u to the 9th. So there's the first term right here. Second term is du dx. And so that is du dx is going to be the 2x. Now we know u is going to be equal to x squared minus 1 from up here, our definition of it. So we put that in there. So we're going to get 10 times x squared minus 1 to the 9th times 2x. Now multiplying out the 10 times 2x, so that's 20x x squared minus 1. And so that is going to be our derivative of this function. And so it's much simpler to do it this way than if we had to multiply x squared minus 1 10 times out. That would be a mess. Let's do one more example. In this example, we want to find dx, the derivative of f composite of g. In this case, f of x is going to be equal to x squared plus 3, and our g of x is equal to 2x plus 1. So we're going to take the composite of that. Now using the chain rule, you can see if we would put in this into that, it would get rather complicated. We can do that and just not bother with the chain rule. But if we're can choose our chain rule and think about it, it becomes a little easier. So now our f prime of x is just 2x, because that's just the derivative of this function right here. And then the g prime of x is just equal to 2. Now, putting this in our formula we saw from the first page, so that's going to be f prime evaluated at g of x times the derivative of f of x. Now, f prime evaluated at g of x, so that's just going to be 2 evaluated at g of x, and that's going to be 2x plus 1, because there's our g of x right there. So that's our f prime evaluated at g of x times the derivative of g of x, so that's a 2. So now that's going to be 4 times 2x plus 1. We can expand that out. That is just going to be 8x plus 4. So there's our derivative. Well, I hope you got something out of this and learned kind of a good introduction to the chain rule. I'm going to do another example. And this is a useful method in mathematics, and you'll see it a lot. It makes things simpler sometimes, so it's a good thing to learn. Thank you for watching, and please leave a comment if you need to. Appreciate it. Bye.